The topic is triple integrals in spherical coordinates. So let's do this example. Evaluate the triple integral over the solid E of square root of x squared plus y squared plus z squared dv, where E lies between the cones z equals square root of 3x squared plus 3y squared and z equals square root of x squared plus y squared over 3, and enclosed by the sphere x squared plus y squared plus z squared equal 4. Alright, so the first thing, I know I'm going to need my phis. So I'm going to rewrite the cones as a phi equal a number. So how do I do that? I can just do it geometrically much faster than algebraically. So geometrically, first I need to, so let me do, the first one will be, let me start with z equal square root of 3x squared plus 3y squared. Alright, so I need to look at the trace of the cone in zy plane or yz plane. So how do we find the trace? We just let x equal 0, plug in a 0 there, so that would be z equal 3 times 0 squared plus 3y squared. This means z equal square root of 3y squared. Y squared is equal 1 over square root of 3z. So y will be absolute value of that, which is just minus plus. Y equal minus plus 1 over square root of 3z, which means z is equal minus plus square root of 3y. Right, of course, absolute value, so if we graph that, we'll get how the graph look like. So this is z equals square root of 3y, this part z equal minus square root of 3y. So I know my slope is square root of 3 over 1. So this is square root of 3 over 1, right? And it goes through 0, 0. Now I know that this is going to be pi over 3, right? Therefore, this angle phi will be pi over 6. So my phi is equal pi over 6. In other words, this equation in spherical is just phi equal pi over 6. Now let's do the same thing with z equal, with the cone z equals square root of x squared plus y squared over 3. Again, we're looking for the trace in zy plane or yz plane. So how do we do that? We let x equal 0, same way, plug it in. So if we plug a 0, let me do it in 2 steps. So that means, by the way, something is wrong here. Square root of y squared, right? Which is absolute value of y, which means still the same, y equal that. So this means square root of y squared over square root of 3 is equal z, which means square root of y squared is equal square root of 3z, right? Absolute value of y is equal square root of 3z. Y is minus plus square root of 3z, which means z is equal minus plus 1 over square root of 3y. So in this case, if we plug it, this is gonna be z equal 1 over square root of 3y. This part will be z equal minus 1 over square root of 3y. So the slope is 1 over square root of 3. This has to be the 2. So this is pi over 6. So the phi that I'm looking for will be pi over 3. So phi is equal pi over 3. Alright, so now let's sketch our solid. We know our solid goes from so let's do first the sphere. The sphere is, let's do it here. The sphere is x squared plus y squared plus z squared equal 4. Now I'm using this equation. This is just rho squared equal 4, which means rho equal 2. So I'm gonna need that. So this is 2. Here's my sphere. 2, 2, 2. Alright, now there are two cones. There is a cone phi equal pi over 6, which is right here. Right? Here's pi over 6. And there is the other one, phi equal pi over 3. This is pi over 3. And I'm interested in, of course this is a cone, right? Is one inside the other one. So how do I do this? And I'm interested in this region between the cones up. So basically, let me do it here so we can see it better. Oops. But I'm interested only on this part. Alright, so I want my phi to go from pi over 6 to, do it here, to pi over 3. So I want my phi to go from pi over 6 to pi over 3. Whereas I want my rho to go from here to here. So rho to go all the way to the sphere, which is from 0 to 2. And I want my theta to go around all the way, the whole revolution. So theta to go from 0 to 2 pi. So let me do the integral here. So integral over e square root of x squared plus y squared plus z squared dv. I want my theta to go from 0 to 2 pi. I want my phi to go from pi over 6 to pi over 3. I want my rho to go from 0 to 2. And square root of x squared plus y squared plus z squared. X squared plus y squared plus z squared is rho squared. You want to take square root of that. And don't forget this definition. We need the rho squared sine phi d rho d phi d theta. Alright, so let's do it here. The rest is pretty easy. We're going from 0 to 2 pi. Pi over 6 to pi over 3, and then square root of rho squared is rho times rho squared is rho cubed. So we're going from 0 to 2, rho cubed sine phi d rho. We're going to do the inner integral first. and then dphi d theta. Now sine phi is constant, so that would be rho 4 over 4 sine phi, and that's between 0 and 2 d phi d theta. Now I'm gonna take sine phi over 4 outside, and then I plug in the 2 there. 2 to the 4th is 16 minus 0. Now I'm gonna do the inside one. Again, 16 over 4 is 4. And integral of sine phi is minus cosine phi, so I'm going to put a minus here, and I want my cosine phi to be between pi over 6 and pi over 3. Alright, now I'm going to go from 0 to 2 pi minus 4. Cosine pi over 3. You want to subtract cosine pi over, pi over 3. Pi over 3 minus cosine of pi over 6 d theta. Alright, what's the cosine of pi over 6 and cosine of pi over 3? I know this is 1, 2, square root of 3. This is pi over 6. This is pi over 3. Remember those two triangles you're supposed to memorize. 1, 1, square root of 2. This is pi over 4, and this is pi over 4. Alright, so sine of pi over 3 will be square root of 3 over 2. We're doing cosine. So cosine will be 1/2. Cosine of pi over 3, 1/2. Cosine of pi over 6, square root of 3 over 2. Right? D theta. What else? Integral of d theta is just theta, so this is going to be minus 4 1/2 minus square root of 3 2 theta, and theta is between 0 and 2 pi. Now I'm going to distribute negative 4. Negative 4 over 2 is minus 2 plus 4 over 2 is 2. 2 square root of 3, and then I want this to be 2 pi. 2 pi minus 0 is just 2 pi. Let me rewrite this. Distribute the 2, so this will be pi 4 square root of 3 minus 4, and that would be the answer. And that's it for this example.